In this video, we're doing Gauteng question paper, of which it's a grade 12 question paper, 2024. This video can be used to practice, so if ever you're using it, you're more than welcome to stop the video and attempt the problems on your own and then see if you're correct. Right, now let's start with the question. So we've got Q2, which is question 2, 2.1, right? Before we even read the questions, let's analyze what's going on, right? So the first thing that we can see two vehicles, a train and a car. Alright, so we have T1 and T2. Okay, let's read the question statement. The question statement is saying a toy train of mass 2 kilogram and a toy car of mass 1 kilogram are attached by a light inextensible string. Okay, so the car train system is pulled up a rough slope. Now this is an important keyword I usually tell my students: underline rough, because if they say there's a it's a rough slope, this means that it has friction. This means there's friction here. So up a rough slope at a constant velocity by the rope, with a force T2 acting on the rope at a 10-degree angle of the inclined plane. Alright, so we have read the statement and now we are good to go. So now explain the term net force 2.1. Right, so that's 2.1. I've written it there. So 2.1, they want us to actually explain the term of the resultant force. Majority of the students, they know this, they know the term resultant force, but then when it comes to explaining it, it's quite hard. It's like explaining why you like something that you do, something bad. It was bad habits that you like, but then it's okay. So the resultant force in simple terms, let me explain it. Let's say we're given two vectors, vector 1 and vector 2, and then you're asked to find the resultant force. Normally, every student is going to be like, this is the resultant force. You use Pythagoras to find the resultant force, of which you're correct. So, when you usually say that, this means you're saying that a resultant force is basically a single vector that is made up by two or more vectors. So you basically, that's how you can say, right? But then coming back to the question, they said explain the term net force or resultant force. So when you're going to explain it, you're going to say it's a single vector having the same effect as two or more vectors together. Now that's the only way you can do it. You can say it that way, or you can say it in the other way of like what's this? The net force acting on the body is the vector sum of two or more forces acting on that body. Though also that one, it's correct. So yeah, you can use that one. You should always check your exam guideline. Your exam guideline will always guide you in the correct way. It should be your Bible in grade 12 by now. Now, when we come back to the question, since we've defined it, we said it's a single vector having the same effect as two or more vectors together. That's the answer for 2.1, right? Now, going to 2.2, draw a free body diagram, a labeled free body diagram for the toy train. Alright, so I'm going to draw two types of free body diagrams, of which I'm going to draw the one that doesn't have the components and the one that has the components. Majority of my students usually say, some of us, we have been taught like this. I do not disagree with anyone. I'm just looking out for every student in ZA, because if there's one thing I've realized is if you don't draw the components, you are okay, but then when it comes to solving the problem, it's going to become more of like an issue, because you're going to then redraw it again with the components, unless if you can see the components without the need of drawing them. So for the train, we do know that there's T2 at an angle, so you can draw it at an angle T2, and we know that there's going to be a normal, and there's going to be an FG which acts perpendicular, and the T1, and again the F, right? F, N, and the T2, T1, and the FG. Then you're done, right? Or you could do it like this, the way I usually instruct my students, but it's okay. Alright, So you could do it like this and say the normal, FG parallel, FG perpendicular, FG parallel, FG perpendicular, right? The FK, then the T1, then the T2 parallel, then the T2 perpendicular, right? Then you're good, because the ones that only have components, it's the FG and the T2, so the others are just good. So this is how you would answer it. Since they say it's 5 marks, they're just going to give you the mark for the normal force, the T2 perpendicular and parallel. The two components are worth 1 mark. Please don't confuse that one. It's just going to be 1 and 2 and 3 and 4 and 5. Yeah. So now let's move to 2.3. Now 2.3, they say the tension force T2 is increased to 20 newtons, causing the system to accelerate up the slope. Calculate the magnitude of the acceleration of the system if the friction force acting on the car is 1.5 newtons and that on the train it's 2 newtons. Thanks Lord they didn't give us the coefficient, because majority of the students, they usually struggle with that one when it comes to using their coefficient, but it's okay. I'm here for you guys. Right, now let's look at 2.3. Now we can see that they told us an important thing. They increased the force. At first it was what? They didn't give us the value of T2 in the beginning, but let's assume maybe it was 10. Now it's 20. Now it's accelerating up, so I want us to find the acceleration. Alright, so we're going to start by saying F net. Alright, I'm moving this thing up a little bit. So F net is equals to MA. Right? So this is for the car. This is for the car. Let's start with the car. And the car, we didn't draw the free body diagram of it, so let's just draw a simple one. It's going to be the normal force Fg, and can we please include the components this time, right? Alright, and it's going to be normal Fg perpendicular, FG parallel, and the FK, right? And you're good to go. So you're going to consider what? So the T1, all of the horizontal forces, of which it's going to be what and what. So T1 minus FG parallel minus FK, which is equals to MA. So now it's going to be T1, it's equals to, what is the mass of the car? The mass of the car was 1, so it's just going to be 1 times A plus what? Plus the 2 of this, plus FG parallel minus the FK. So the FG parallel, let me write it in its component. So we know that FG parallel is going to be 1 times 9.8 sine 20 degrees, right? It's for the FG parallel, 20 degrees. The reason why, it's because when we look at it in this form, the FG is always acting downwards perpendicular, right? So there's an angle here. So if this angle, let me use a different color so that I can show you. If this angle here, if we're looking for this side, which trig ratio are we going to use? We're going to use the sine, right? But in this case, we're not going to use the sine for the one below, right? Let me not confuse you, but then you see. So it's going to be 1 times 9.8 sine, then minus, not minus, plus FK, which the car is 1.5. Then the T1, you should get A plus 4.8, right? Let me double check on my calculator. Did it with my head. And 8 sine 20 plus 1.5. Yeah, 4.8. Yeah, 4.85. Oh, now let's go to the second one. Now remember that the mass of the train is 2 kilograms. Right? Please remember that one, since we're going down now. So you're gonna say the train, of which we're going to say the F net is equals to MA. Now we're going to look at the train with its component. Now you see how efficient it is. Now we're just looking at that diagram and coming back. So we know that we're going to have the T2 parallel and minus the T1 minus the FK minus the FG perpendicular, right, which is equals to the M. So the mass of this one is 1 kilogram. Now the mass of this one is 2 kilogram. We can even double check. Yes, it's 2 kilogram. So we're gonna then say T1 is equals to 2A. Then we're gonna add this ones. So for this one of the FG perpendicular, it's not supposed to be perpendicular, it's supposed to be parallel here. Made a mistake, sorry. Now for this one, since it's parallel, it's the same story as that one, right? So I'll also do it that way also, just for safety's sake. So we're going to say plus 2 times 9.8 sine 20, and then we're going to look at the FK. Then we're going to say plus the FK, which was 2, then plus FK, it's 2, the FG parallel, and now we're going to look at the T2 parallel. Now for the T2 parallel, let's look at it carefully. T2 parallel, they increased it by 20, considering this side, right? And this is the angle, which trig ratio consists only of the adjacent, the cos, correct? Now then it's going to be plus the 20 cos 10. Now this means my T1 is going to be 2A. It's going to be 2A. Remember this minus, by the way, guys. It's going to be 2A. The reason why it's a minus, it's because here, right? So it's going to be 2 times 9.8 sine 20, and then plus 2, then plus 20 cos 10, right? So my answer, it gives me 10.992. Yeah. If yours doesn't give you that, you should check it. Let me do it again so that we can be sure that we are in the right track. 19.6 and then sine 20. Alright, let's see. Yeah, my answer is giving me 20. It's going to give me 10. Yeah, 10.992. Unless if someone is getting a different answer, but then yeah, that's my answer right here. I'm getting 10 point. Let me double check something quick. This is our FK. FK it's 2, and this is our FG parallel. This is this one here. It's a plus. This one is a plus. This one is a plus. Oh yeah, I see why. Yeah. Now I see why someone was complaining. Yeah. The reason why, it's because of the T2. The T2, once you take it to the other side, it's going to be minus, right? Please don't make that mistake. Right, now we're getting the same answer, which is the one that I was saying, which is 10.992. Apologies for that one. So it's minus 10.992, which is going to be T1 10.992 minus 2A. Right, now since both of them are equal to T1, we can then equate both of them to each other, right? We can just say T1 is equals to T1 and say 10.992 minus 2A is equals to A plus 4.85. So from there on, we can take this one, it's going to be minus 3A. Yep, it's going to be minus 3A, which is equals to the 10.992 minus 10.992. This is another 16, and plus the 4.85. Then the A is going to be what? So it's going to be 10.992 Negative 10.992 plus the 4.85, and we divide it by 3. And our answer is supposed to be 2.047 meters per second squared. Now that's our acceleration for this problem, right? It wasn't quite that long because they would have asked for the tension, then we would have done a lot of work. Now let's go back to the question and see what they want for 2.4. Now for 2.4 they say halfway, right? So they say halfway up the slope, the string T1 breaks. Okay, okay, and the car rolls down the slope. Does the friction force on the train increase, remain the same, or decrease while still moving up the slope? Now let's look at this. They're talking about the friction force here, right? This one doesn't need calculations unless if one wants those calculations. This is a quite interesting question. We have to look what affects friction. So when we define Fk, it's defined by the normal force and the friction coefficient. So now they said, what will happen? Will the friction in the train change? Will it increase, decrease, or remain the same? Now look at it. Does the normal force change when it loses the car? When the T1 snaps, does the normal force of the train change? No, it doesn't. So then this means it just remains the same because the normal force, it doesn't change. The normal force stays the same, therefore it remains the same. So since it's 3 max, you can say it like this: it remains the same. You say 2.4, it remains the same. This is the answer. Remains the same. I'm just gonna write this one here. It remains the same, and the reasons being that the normal force stays the same. It's not affected by the loss of the car, and frictional force, basically we can see it's directly proportional to the normal force. And to show you, this is how I can show you. You can just say the normal force is equals to Fk divided by the friction force, coefficient of the friction, divided both sides by the coefficient of the friction. So this means that if this side increases, this one would increase, but if this one decreases, this one would increase. So yeah, so if the normal force increases, the Fk increases. So that's the answer for this one, guys. So we have reached the conclusion of this video. As always, please comment below, and if you don't understand anything, you're more than welcome to comment. And if you want to join my private classes or sessions one-on-one, you're more than welcome to email me. I'll provide the email below and the cell number. Right, so enjoy the rest of the day, and I hope to see you in the next one.